are called hydrogen displacement reactions. So these species, magnesium can displace chlorine from titanium chloride, and for instance, magnesium chloride is displacing a metal. So it's a metal displacement reaction. Similarly, a halogen can be displaced. That would be called as a halogen displacement reaction. So these are this type of reactions. Okay?
Can you post this slideshow on campus?
Right.
She's like,
Okay. So let's get into this. I want to talk about this one in particular. Okay, so we talked about the different types of oxidation reduction reactions, right? So in this previous slide, we saw that strontium, what is strontium? It belongs to group 2, right? It belongs to group 2. Strontium is displacing hydrogen from water, okay? So there's evolution of hydrogen gas, okay? So this producing strontium hydroxide and producing hydrogen gas. Now, if you had gold here, can it displace hydrogen gas from water? No, right? How do you know? Because you know, because gold is supposed to be not very unreactive in nature. That's why people buy gold, right? Because it's such a precious element, because it's unreactive. It can stay like that for years and years to come. Right? Now, this is basically guided by what's called as the activity series. We're going to take a look at that activity series, okay? So, okay, that's the activity series for metals. It's on, this list is going to be provided to you in your test. Okay, so you don't have to memorize it, but you just need to know how to use it. This is page, activity series will be provided to you. Is figure 4.16 in your book, okay? So according to this series, okay, any element that is above hydrogen, okay, so please pay attention. There is hydrogen right here. Okay, there is hydrogen right here. Any above that is above hydrogen, any element that is above hydrogen is going to displace hydrogen from water or acid. Okay, that's why strontium was able to produce hydrogen from strontium hydroxide from water.
From water or what?
From water or acid. Any metal above hydrogen will displace it from water or from an acid. Metals below hydrogen will not react with either water or acid. So this is hydrogen right here. So you just need to look here, right? Basically, you should know how to use this activity series. If it's magnesium can displace hydrogen from water. It can produce magnesium hydroxide plus hydrogen. Okay? If it's mercury is not going to be able to do so because it's below the series. This is already a found, it's already been calculated, not calculated, scientifically proven, right? We use this series to basically tell the activity of a metal. That's that, okay? So any metal above hydrogen will displace it from water or from an acid. Metals below hydrogen will not react with either water or acid. And according to this series, now lithium is the most active metal. It's at the top of the series, and gold is the most unreactive metal. Not getting it?
now it's just.
Okay, so this is basically just learning it, okay? There's you just okay, any metal, this is hydrogen here. Okay, this is called the activity series, also called as the electrochemical series, this chart. Okay, we should know how to use this chart. According to this chart, basically, any metal that's above hydrogen, these metals, lithium, potassium, barium, calcium, sodium, they're going to react, okay, and displace water and displace hydrogen from water. We'll take a look at a particular example, just like here. Strontium, right? It's reacting with water, produces strontium hydroxide plus hydrogen. Okay, now strontium it's not shown here, but it's going to be above the list. Why is it not shown? I don't know. Okay, so maybe there is, okay, calcium. Calcium is right here. Okay, calcium is going to react with water and produce hydrogen. Okay, now gold cannot do the same thing. Okay, gold is AU, cannot do the same thing. It cannot produce hydrogen from water. Yes?
So is it like with halogen displacement, hydrogen displacement, is it like you're displacing like the H or the halogen out of each?
Yes, yes. You just displace, it's a displacement reaction. It just tells you if you can displace hydrogen or halogen from water or acid or not. Okay, so maybe when we go to one more slide, we will clear. Okay, now there's another series for halogens. Okay, so fluorine is more reactive than chlorine. Okay, fluorine is in group 7A, right? Group 7A, that's the first element there, right? Fluorine, when you go to group 7A, look into the periodic table. That's the first element, fluorine, then bromine, then iodine. Right? So fluorine is more reactive than fluorine is more reactive than bromine, and bromine is more reactive than iodine. Okay? So chlorine, this is chlorine, molecular chlorine, okay, can displace bromine from potassium bromide, okay, because it's more reactive than bromine. Okay? So it can displace some bromine from potassium bromide and produce potassium chloride and bromine. Okay? But bromine is not going to be able to do so with chlorine. Bromine will not be able to do so with chlorine. Or the example shown here is about with iodine and bromine. Okay, so iodine cannot displace bromine from potassium bromide. Is it clear? No? Partially clear? So which is more reactive here? Fluorine, right? So fluorine can displace, if HCl is given, it can displace chlorine from hydrogen. So if it's fluorine, right, and HCl, okay, this fluorine is going to displace chlorine from hydrogen chloride, okay, and it's going to produce hydrogen chloride plus fluorine, okay, okay. That means this is more reactive than chlorine, so it's able to do that. But fluorine is not going to be able to do so with hydrogen chloride because it's not reactive, because the backward cannot go. It cannot go backwards. Alright?
So it's basically it breaks them apart.
Yes. It's displacing means taking that position, right? Displacing. I want to get there, but I want to do a few examples before I get there. Alright, so since copper sulfide plus HCl. Okay, use the activity series. Okay, so the activity series will be given, okay, with your periodic table. Copper plus HCl. Can this reaction take place? From using the activity series. Copper plus HCl. Can this reaction take place? No, because copper is below hydrogen. Right? So it cannot form copper chloride plus hydrogen. This reaction will not take place, okay, because it's below hydrogen. Okay?
So whatever's below it,
No matter what.
No matter what, right?
so it has to be above it.
If it's above it, then it can displace it. Let's do one more. Magnesium plus copper sulfate. Okay, so what would you project? Magnesium plus copper sulfate. Magnesium is here, copper is here.
So it can?
Can it displace?
No.
It can. Magnesium can displace. Yes, so it can displace.
So the
So
bottom
it has to
two
be
can.
the first one to be, okay, got it.
So the first two can, the bottom two can.
This is because magnesium is more reactive than copper, so it can displace.
So those bottom two that says react with acids and then non-reactive, they both don't. Never mind.
It's not. It could be with any other like
Will
copper
you put
sulfate.
this chart on the test, or we have to know?
No, you'll be given.
Okay.
You should just know how to use it.
So if it's below those two, they're not reactive.
Well, okay. So magnesium and copper, right? So it's not magnesium. We're not dealing with magnesium and hydrogen. Any element that's below it, okay, can be displaced by the one above it. Any element that's below it can be displaced by the one above it.
Okay.
Okay. How about okay. I got it, right? You just need to know how to use it, basically. That's it. Okay, so let's get into stoichiometry. I didn't have time to do everything, but so I'll give you guys a assignment from this chapter, and please do those. And if you have questions, we can discuss it tomorrow. Okay? But we want to get into stoichiometry. Okay? Okay, so there are a few things here. M equals to molarity. M is called as molarity. Okay. Now this big M, it's always big M. Okay, it measures the strength of an acid or a base. It measures the strength of a solution. Okay. This molarity equals to moles of solid over liters of solution. It's always equals to moles of solid over liter solution and is represented by the big M. It's a way of measuring the strength of an acid, base, or any solution. Okay. So the concentration of a solution is the amount of solid present in a given quantity of. It doesn't make any sense. I should have erased that. But basically, molarity is used to measure the strength of your solution. Okay. Now. We often work with, different stock solutions of hydrochloric acid, sodium hydroxide, etc. in the lab, right? And we often report it as 2 molar HCl or, 2 molar sodium hydroxide. Okay? Right, so basically when you're preparing, or you'll just write it as 1 molar sodium hydroxide. Okay? So 1 molar sodium hydroxide indicates, what does it indicate? So the strength of the solution is 1 molar. It indicates
6.
no.
Wait, what do you have?
No. So 1 molar sodium hydroxide, what does it indicate? It indicates the strength of sodium hydroxide, right? So basically, how would you prepare 1 molar sodium hydroxide? How do you prepare?
So would you do like, you'll let the molar mass?
How do you prepare? Yes, you need a molar mass. How would you prepare a 100 milliliter of 1 molar sodium hydroxide? Okay. How would you prepare a 100 milliliter of 1 molar sodium hydroxide?
So find the molar mass of each.
Right. So basically, you want to prepare the volume is 100 milliliters, and the strength is 1 molar. So let's start with formula mass of sodium hydroxide, because we need moles of solid, right? Formula molar mass gives you grams per mole, right? What's the molar mass of sodium hydroxide? It's about 40, isn't it? Sodium is 20, should be about 40. What is it going to be?
The molar mass of what?
Sodium hydroxide. 23 plus 16 plus 1 is about 40.
40.
40. Let's just use 40, okay? I'm just going to use 40.00. What is it? 0? Okay, 40.00 grams per mole, right? We have that, and we want to prepare 100 milliliter solution. That's molar mass, right? So the volume we need is 100 milliliter. Okay. Now, how would you prepare this? That means how much sodium hydroxide would you weigh out, from like a big bin and dilute it and make a 100 milliliter solution?